Is that working now? Can you hear us now? Oh, that says it's working there, right?
Yeah.
Oh, someone say yes.
Oh, yeah.
Ah, okay, let's try that. No, this will work.
Yeah,
Right.
that should.
Is that working now? You can hear that okay? Okay, thank you. Sorry about that.
Thanks, Matthew.
I don't know what happened there. Okay, so sorry about that. We're using this new software for this conference, and largely it seems to have worked okay, but not completely. So as I was saying, I got this book on interdisciplinarity, and I kind of read it. And I thought, oh, I better see what the literature is on this kind of thing. And I found it really interesting, actually. It's quite. I thought it was quite an intriguing, well-developed area of study, interdisciplinarity. And it turns out there's a plethora of contrasting types and ways you can analyze interdisciplinarity. Here's a table of different sorts of distinctions that people make when talking about interdisciplinarity. And I kind of looked through these, and I thought that what one was particularly interesting was this difference between, this particular interesting difference between bridge building interdisciplinarity and restructuring interdisciplinarity. And the difference between these things is bridge building, so says this book, occurs between complete and firm disciplines. So you've got these two different disciplines and they kind of interact in some way. Whereas restructuring interdisciplinarity happens when you detach parts of several disciplines to form this new discipline, this new coherent whole. And the formation of new interdisciplinary fields is a really major case of restructuring. So I wanted to sort of reflect a bit on this. So many of you from the philosophy of mathematical practice community will be familiar with this paper, where Benedict Loewe sort of discussed and reflected a bit on the nature of the philosophy of mathematical practice. Now, this is a bit old, so I don't know if this is still his view or still the views of, if it still reflects the views of people in the philosophy of mathematical practice world. But what did he say? He basically said that the right way of conceptualizing the philosophy of mathematical practice is as a bridge-building interdisciplinarity community. So he said a field that coheres enough, so it's PMP is a field that coheres enough that the community members collaborate, publish jointly, regularly meet at conferences and workshops, set up networks together, but still remain part of their respective disciplines. And he really wanted to emphasize that the disciplines are distinct. Nevertheless, people from these different disciplines agree on the subject matter. So he says, we can and do agree that the subject matter is mathematical activity as practiced by human beings. And this I think is very peculiar, but this was his argument. He said that the primary way of defining a discipline is the research method used. Therefore, PMP cannot be a discipline because it uses a wide variety of research methods. I think on that definition, very few disciplines are actually disciplines. So I find that a bit peculiar. But really the point he was getting at is that PMP is a bridge building discipline, so it's important to have these interdisciplinarity workshops. And my reading of his article is that's what he thought should happen. That's, it's a big deal about the importance of going back to your disciplines and meeting the standards of the fields in those disciplines. But there are other types of interdisciplinarity, as we've seen from that distinction. And I wanted to talk a bit about the development of cognitive science, which is like a really clear-cut example of restructuring, interdisciplinary restructuring. And it's given as such in this handbook of interdisciplinarity. So what is cognitive science? Well, this is the Johns Hopkins Department of Cognitive Science's definition. It's the study of the human mind and brain, focusing on how the mind represents and manipulates knowledge and how mental representations and processes are realized in the brain. And they say cognitive scientists share the central goal of characterizing the structure of human intellectual functioning. And importantly, it integrates traditionally separate disciplines into this new field, this restructured field of cognitive science. And there's this famous diagram from Howard Gardner's book in 1985, where he draws this diagram showing the different fields involved in cognitive science, and talks about how well they were connected in 1978. So he says, well, look, you've got these traditional 6 disciplines involved in cognitive science: psychology, philosophy, linguistics, anthropology, neuroscience, and artificial intelligence. Some of them are better connected than others, and he illustrates that with broken lines and unbroken lines. And that was what the situation was in 1978. So what's interesting there is he positions, notice education's missing, although a modern day version of this diagram, this is the logo of the Cognitive Science Society, which I've always assumed is based on that Gardner diagram. I don't know if that's true. But education is included alongside the other 6 in this more modern way of conceptualizing cognitive science. So what you notice from this is that the 2 disciplines we're talking about in today's workshop, well, this week's workshop, are both deemed to be important components of this restructured new interdisciplinary field. Okay. So here's the interesting question: is like, why don't we really talk much about the cognitive science of mathematics? So what would that be? Well, remember, cognitive scientists share the central goal of characterizing the structure of human intellectual functioning. So that doesn't sound that dissimilar to what Benedict was saying is the goal of PMP, but he didn't conceptualize it as a restructured interdisciplinary field. Okay, so really this is what I want to ponder on a bit for the rest of the talk. So while I do that, let me just give you a bit of personal history. So I did my PhD on the role of conditional reasoning in mathematics, and I did it in an education department at the University of Warwick, but I spent about half my time in the psychology department working in the visual attention lab using their eye trackers to help me do that. Despite it nominally being an education thesis, my thesis had essentially no educational implications at all. No one seemed to care about that. And I did use methods that were traditionally used in the psychology of reasoning literature, which was really unusual for maths education research. But I also used techniques and theories that were much more commonly used in mathematics education. So this meant I ended up submitting papers to education journals using methods more traditionally associated with psychology. And this caused loads of problems at that point in time. So here's my first example of rejection letters. So this was a rejection I got in about 2004, I think, the first time I ever submitted an article to a journal. And this was deemed to be a complaint. The literature reviewed comes mostly from psychology. What does the length of time spent on a problem say about the way people reason? Which is essentially, a really basic assumption of cognitive psychology is reaction times tell us something important about the complexity of the processing. The methodology of the study and the models used in interpreting the results are extremely simplistic, and dual process theory, which at the time just won a Nobel Prize, is an extremely rudimentary model of how people think in mathematics. Okay, so I was like really quite annoyed at the time. I was quite upset about this. Wow, what chance is there of working in the interface of 2 disciplines when you get reviews like this? The overarching summary of this was the reviewer who wrote this. If the editors of this particular journal are of the opinion that the work of cognitive scientists, when I reread, the first time I've noticed that this person assumed I was a cognitive scientist, which is interesting. Working on logical processes is to be considered as an integral part of the output of mathematics education. I would suggest the paper is accepted. If, however, the opinion is that established results of cognitive scientists can be questioned as to their significance in a broader context from a mathematics education perspective, then it should be rejected. I would lean to the latter point of view. Okay. Now, interestingly, at the same time, I think it was pretty hard getting stuff published about mathematics in psychology journals. So this is the first paper I published as a first author in a psychology journal, and it was about children's numerical development. So it's about the role of the approximate number system in children's numerical developments. It's a really, really central question in numerical cognition. What's the cognitive underpinnings of numbers, essentially? And I got this like really quite nice, so this is a Psychonomic Bulletin and Review, is a generalist psychology journal. I got this kind of nice but peculiar bit of feedback from the editor in the first round of reviews. So the editor said, I did have a bit of worry of my own. Psych Bulletin and Review is a general audience journal, and it is important to its remit that articles be of interest to a wide audience. For this, it is essential not only that your data are as strong as possible, but also that the topic has widespread appeal. Remember, the topic is how do children learn about numbers? Right? I found your manuscript well written and clear with regard to the question you were addressing, but I was not entirely convinced of the broad appeal of the underlying issues, and I would ask you to spend a bit more effort on setting out why your experimental question is of general importance. And this also frustrated us. You would never get that comment if you were a reading researcher studying how people learn about phonics or whatever. So a basic summary, this is my impressionistic view. In this period where I was a PhD student and a postdoc, using psychological theories and methods in works a bit to mathematics education journals was really hard. You upset reviewers and you got aggressive rejections. And submitting studies about mathematics to psychology journals, they weren't quite as aggressive, but they were very skeptical, I think, of like, why do we care about this? You know, why does anyone care about mathematics from a psychological point of view? So if I adopt Gardner's diagram, I'm anticipating someone will ask me why artificial intelligence isn't on here, and it's simply because I couldn't work out how to do a 7-sided shape. So there's nothing, so don't worry about that. But I think in 2005-ish, this was the situation. There wasn't much connection between these disciplines, other than there's always been a strong connection between mathematics and mathematics education. Of course, there's always been a strong connection between philosophy and mathematics, but there wasn't really any other connections. There wasn't much work on psychology as related to mathematics. There wasn't much neuroscience. There was a bit, but not much, and there wasn't much anthropology. Okay, so some time ago, Camilla Gilmore and I decided to sort of try and address some of these issues. And we got a bit of money from the British Academy and Nuffield Foundation to run this workshop, which actually, I'm thinking back, is very much a precursor of this, I suppose. So this was in 2007, and we got a load of people. So we got some mathematicians, so Sasha Borowicz, many of you will know, and Peter Bryant, very distinguished cognitive psychologist, Marcus, who was online yesterday, maybe online today, I don't know, Marcus Giaquinto, a very distinguished philosopher of mathematics, Teresina Nunes and David Tall on the sort of educational wing. And we got people to come and talk about this. And I enjoyed that conference a lot. It was interesting. I don't know how successful it was, and we weren't sure if it made a big difference to this notion of this interdisciplinarity working together on mathematical thinking. But on reflection, preparing this talk, I think there has been a big change in the state of things since about 2005. So my main claim is that there has been a massive change since that workshop, not attributing to the workshop, of course, but since that period, I think there's been a really big change. I think we now have a genuine cognitive science of mathematics has developed, typically called mathematical cognition. I think this is a genuine case of restructuring interdisciplinarity, not bridge building interdisciplinarity. But philosophers haven't really been involved in this at all. But the rest of the people on that diagram that Gardner showed have been. And I will try and evidence these claims in the next section of the talk. So basically my claim is, when I finished being a PhD student and postdoc, the world looked like that. Now it looks like this, but you've got this, this group over here who are only dotted. Okay, so what's my evidence for this? Well, if you do a sort of bog standard publication search, if you search for articles that use the phrase numerical cognition or mathematical cognition in the abstract or titles, you get a really exponential growth since about 2000. So these numbers were really small here. They're pretty respectable now. And of course, this only captures a small proportion of articles that are actually about these topics, because this is only ones that use that exact phrase in the title or abstract. But even with that crude measure, you can see there's a really big growth since about, I don't know, 2005 and continuing. You can write books about this now. You can write books about mathematical cognition. This is one that Camilla Silke Goebel and I wrote, and people buy them to the extent that you're asked to write second editions, and they give them awards. I think that just wouldn't have been possible in a world where you have to justify why anyone's interested in how people think about numbers. You might be thinking, maybe this is just psychology. Maybe mathematical cognition publications are just psychology. It's not true. So if you rely on the Web of Science categorizations, you can see it is dominated by experimental psychology and neuroscience. So this is the same data set as that graph, the exponential growth of that graph. But there are, a respectable number of education publications. You've got to be very skeptical of these kind of categorizations because it's very error prone. I don't really know what that means. For example, behavioral sciences is a sort of catch-all term. Some people would say a bit of developmental psychology is ambiguous about the boundary of that, and some bits of education is. But nevertheless, the clearly educational ones are respectable. There's a respectable number of those. There is some philosophy using these phrases, but not very much, about a third as much as the narrow education category. Just some examples, which I thought that was kind of interesting. So this is a paper, an education paper, according to the Web of Science, about mathematical cognition by my colleague Francesco Sella, who's not at the workshop, interestingly. I think that also tells us something important. We'll get onto that in a minute. And Roy Cohen-Kadosh, who are interested in expertise and what that tells us about mathematical learning from a kind of neuro perspective, I suppose. So what's in the philosophy category, you might ask? Well, it's Brendan. Brendan is the exemplar here. Good. Okay. Fourth bit of evidence. We now have this really flourishing set of infrastructures that focuses on this, what I'm going to call, for the purposes of this talk, the cognitive science of mathematics, but what most people would call mathematical cognition. So there's a successful open access journal now, which publishes high quality work and is high quality, serious researchers publish in it. We have this Mathematical Cognition and Learning Society, which just had its 6th conference here last week, which I think was a success. Philosophers don't come to it. I was thinking back this. I've been to every one of these conferences. The only philosopher I think who's ever come to it is Dirk. And he only came to it once. And only really because I bullied him into coming. Yeah. But there are lots of people who do come to it. So it's a serious big conference. So last week there were 400 people here from 30 countries. And it's growing year on year. So it's a serious endeavor. And the people who come to the conference, again, you might be thinking, well, are they just presenting cognitive psychology? No, they're absolutely not. And that's one of the interesting things I took away from last week. So this was an example of a symposium I went to. A symposium on registered reports on intervention studies, which David Papura chaired. And this is not a topic that you could present at, say, the Experimental Psychology Society conference. This is a overtly interventionist, education-focused, take results of cognitive psychology, try and turn them into interventions and evaluate their effectiveness. So it's not the case that this is just a cognitive psychology conference focused on mathematics. 5, we successfully persuaded Research England to give us a load of money to set up a Centre for Mathematical Cognition, which I think would have been really hard if it wasn't a proper thing. And this is the grant that's paying for this workshop. So this is I think an important bit of evidence that it's also a cost if philosophers don't want to get involved in this interdisciplinary field and miss out on a lot of money. And then subsequently, we persuaded the ESRC to give us another big tranche of money, which is also focused on what I'm going to be calling the cognitive science of mathematics. So you can get funding for this. It's not just which is pretty hard to get funding for education research in the UK, at least theoretically focused education research. Okay, I no longer get the kind of reviews I used to get when I send psychologically focused papers to mathematics education journals. So I can't remember the last time an education researcher asked me what a reaction time tells you, and I can't remember the last time I had to explain how you can include causality from an experiment, which I have had to do before to education researchers, reviewers, I should say. I don't think that happens anymore. At least it doesn't happen to me. Obviously, that's a small sample. I think the reason for that is interesting. Partly it's because there's serious, important people in the mathematics education community who are mathematical cognition people. So Wim van Doren is president of PME at the moment and an editor of ESM, which is one of the leading journals in mathematics education. And Stefan Ufer is an editor of Learning and Instruction, which is a very, very serious general education journal. I think that's a big change. Okay, this is the fun bit. So I do still get reviews from philosophers, which really strongly remind me of the reviews I used to get from education researchers. Okay, so let me give you some fun examples. So when I look back to find loads of these. So, okay, this is pretty tame, but this is a review we got recently. This article has insufficient genuine philosophical content. I was intrigued that that was inverted commas. I wasn't sure, what does that mean? I wonder what's the implications there? I don't know, but okay, fine, you know. This article is not a scholarly piece of work and lacks substance. I've no critique of the study, but the similar kind of, it's not scholarly. And this is my favorite ever review. I would go so far as to say that out of respect for the author, the paper should not be published anywhere. Oh, okay. Thanks. But you see my point, this really is quite reminiscent of the reviews I used to get when I sent psychological papers to education journals.
Well, Matthew, do you feel able to tell us which journal?
I don't know. I mean, I don't mind telling you that over, for the people online, Brendan just asked me which journals these reviews came from. Perhaps I shouldn't broadcast that over the internet, but I'm happy to tell you that over a drink. Okay. Here's another bit of evidence. So that is a lineup of my colleagues. These are the people we appointed using money from the Centre for Mathematical Cognition grant. So that's £7.2 million. Here's a selection of them anyway. So all of these people notionally have an affiliation to mathematical cognition and as a discipline. But I think we're probably the largest group we're certainly the largest group in the UK, maybe Europe, maybe the world, I don't know, but we're a very large group of mathematical cognition researchers. If you send them an advert saying, look, we're hosting a workshop involving a load of philosophers, how many of them turn up, right? Well, Colin did, but he had to do a talk. I don't know if he would have anyway, we can ask him that.
Then you think more of them would have come if you hadn't had them till us here last week?
It's just, yeah, maybe. Well, Christoph came just for the lunch, though. Anyway, you get my point, right? I think the philosophy as a discipline is not very visible in the mathematical cognition world. Okay, people who work on mathematical cognition at the moment don't regard philosophy as particularly relevant, which is a shame because in general cognitive science, philosophy has a long tradition of being relevant and a part of that restructured discipline. I'm being a bit unfair because Beth's been here, although not today. Okay. Okay. Chris came. Yeah. Okay. So some people have, but you get my point, right? If this was okay, so if you accept that whole stream of evidence, then since about 2005, there's been this restructuring that's led to a new field, a sort of cognitive science of mathematics, or mathematical cognition, which has followed very precisely, I think, the way this interdisciplinary handbook describes the process of restructuring. So if cognitive scientists share the central goal of characterizing the structure of human intellectual functioning, I think it's really reasonable to say mathematical cognition researchers share the central goal of characterizing the structure of even mathematical functioning. But the big claim I want to make is so far, philosophers haven't really got involved in that, with some exceptions, of course, but as a rule, largely not been involved. So, I just want to preempt an objection that Keith will make based on a conversation I had with him at dinner. I'm absolutely not saying that most, or even many, maths education researchers are engaged in this new field. That's not my claim. I'm claiming that there is a new field and that mathematics education is an important part of it, because there are plenty of mathematics education researchers who are very visible in this new field, and the topic of the new field is influenced by that. And I think the David Purpura Symposium is an example of that. But that's different to philosophy. I don't think that is the case with philosophy, and I think that's a shame. Okay, so that was the situation in 2005. We're now in that situation, I think. Why? So here's the next question: why? I think there's kind of reflecting on this, and I think there's different reasons why this might be. Some of which are good reasons, some of which are very, very bad reasons. So I think there's two categories of reason. There is practical reasons, and then what I'm calling deeper reasons, some of which are good, some of which are bad. So let's get the practical reasons over and done with. So I just think it's actually quite hard to do philosophical research from this perspective, because you just have no confidence what's going to happen. So I just don't, if I'm starting a project on a really overtly philosophical issue, it's really hard to have confidence that I'm going to be able to publish it outside of edited books that people in this room and others often invite me to contribute to. But that's a very error-prone process, because who knows when the next edited book is going to be available, and journals are just wildly unpredictable, it seems to me, philosophy journals, in how they react to this kind of work, as I've shown you with those previous reviews. And it's not that it's impossible to publish this sort of work in philosophy journals, and I've done some of that myself, but it's wildly unpredictable. So you think, well, what about using the journal for mathematical cognition? Oh, yeah, have you reviewed for JNC? Yes. Have you? Oh, interesting. Okay. What did you review? Okay, we'll talk about that later. I'm intrigued by that. Anyway, point is, I think there hasn't been much published, at least. I attributed that to because the lack of philosophers in the research community. But maybe I'm wrong about that. Maybe if we did send a philosophical paper to the JNC, it would be published. I also don't have any confidence that I'm going to be able to present such work, because other than this sort of irregular workshop, of which there are a lot, to be fair, it's hard to see where you would do that. And I don't want to rely on irregularly organised workshops. And this has a real consequence, because as a result, when I do get an invite to write a book chapter or give a talk at an irregularly organised workshop, I often just don't have anything to say, because I haven't had enough lead time to do the research required, because I'm nervous about starting projects in this area because I don't know how to publish them. Or I just don't know reliably how to publish them. So I think there's this whole suite of practical reasons which cause barriers to this integration. Okay, so the more deeper reasons. And we've discussed some of these already in the workshop, so I'll give my views on some of them. So I think some philosophers, even PMPers, actually aren't interested in doing this. And we've talked a bit about that already in some parts of the conference. Although I think some are. And I think there's bad deeper reasons, and I touched on this yesterday. I think there's a lot of very strange disciplinary essentializing that goes on with philosophy, and I'll give an example of both of these now. Okay, so let's. So Sylvia reminded me of a discussion I had with her in Prague in 2019, again after Fenner's talk, and yesterday Sylvia mentioned Marcus's reaction to an experiment we once did which touches on this issue of when two proofs are the same, or should we only talk about proof presentations? And I just want to sort of motivate where I come from in this view, because I think it does suggest actually a serious difference in goals, which is probably important to clarify. So I just want to talk a bit about this paper, which is a thing that Pablo and I wrote in 2009. I think, Andrew, that was your special issue, wasn't it?
Right.
Yeah. So it was about the persuasiveness of visual arguments. And we presented a load of mathematicians with this statement of Young's inequality and a picture proof of that. Well, picture, inverted commas, proof of that. And I don't want you to bore you with the details of looking through this, but we showed them that, and then we asked them this question. The given evidence suggests that the claim is definitely true, and then degrees of less certainty, right down to this gives no useful information about the claim. Okay, so the question we were interested in is what sort of evidence do mathematicians perceive this kind of proof, in inverted commas, to be? And we gave them two conditions. What we called the no description condition, which was just this diagram, and the description condition, which was that diagram plus some text describing the diagram. And we were very careful to make sure that the text had no deductive content at all. It just describes the diagram and then says, notice the relevant thing of the relevant thing about the diagram. And I think, based on what Sylvia was telling me, if any two proofs in inverted commas are going to be the same, it's going to be these two, because they are absolutely identical in terms of deductive content, if there is any deductive content. But, if you're ever going to say, the only difference is you describe the picture in words. Okay. I won't stop and check that, but I'm pretty confident that must be true. That people who say that there is some generic notion of proof would want these two proofs to be the same proof. But it turns out that they really have quite seriously different effects on the mathematicians. So if you just add that description, mathematicians are 3 times more likely to say that that evidence is definitive. 3 times more likely to say that that evidence means that the claim is definitely true. Okay. So I think that if you do want to conceptualize those as the same proof, that really does gloss over important and interesting differences that it's important to understand. If you want to understand human mathematical functioning, you do need to have some mechanism for distinguishing those two types of thing. Otherwise, you're going to miss out important things. So my conclusion is the fact that there seems to be this very strong aversion amongst some people to doing that tells us something about what their goals are. And I think probably what that tells us is their goal probably isn't to understand human mathematical functioning, but trying to understand something about mathematics itself. Fine, that's obviously that's fine. But I kind of weird, like why PMP though? Doesn't feel like a PMP goal, but maybe it is. Anyway, so I think we need to clarify that. I think we really need to clarify what different people think the goals of their wider research is. Okay, here's the bad, what I'm going to claim as the bad, deeper reason. So we've had a lot of stuff on explanation. I'm going to add to that. I think some judgments, and I've spoken informally to some people about this already at the conference, about what some philosophers think philosophy is just baffling to me. So let me tell you this program of research that Pablo and I have done, involving also Tanya and Colin Ripberg. So we wrote this paper about functional explanation, which is essentially putting forward the claim that explanation is all about understanding. Okay, so what was that? Well, that was taking this paper, which was written by Daniel Wilkenfeld, a philosopher, published in Synthesi, a philosophy journal, which is a new approach to the philosophy of explanation. So this is a philosophical account of explanation outside of mathematics, which relates to understanding and explanation in a very direct way. What we conceptualize ourselves as doing is simply taking this, notice the keyword as well, philosophy of science is a keyword there, taking this philosophical account and just applying it to mathematics and then using that to say something about other philosophical accounts. then we did some other bits and bobs as well. So, let's look at general philosophy account, published in a philosophy journal, written by a philosopher. Tried to show how it accounts for previous philosophical accounts published in philosophy journals written by philosophers. We then published that in a philosophy journal, and then did some other publications on the same theme, also in the philosophy journal. But then Sylvia described this as being from a mathematics education perspective. I think, what? I don't understand. Why? Why? Other people, sometimes when you present this, people say, well, that's not philosophy. And I don't understand what philosophy is. So this is my big question in bold. You know, how can this be true? How can it be taking a philosopher's philosophical account, applying it to other philosophers' philosophical accounts and writing it in a philosophy journal? How can that be mathematics education? I don't think it possibly can be. So I think that's a problem, because I think if you do that kind of essentializing, you create these artificial boundaries, you create weird group criteria memberships, you really hamper interdisciplinarity, and I think ultimately you lead to less progress. Much better attitude is the attitude that my PhD supervisor, Derek, said, and I mentioned this over dinner to some people last night. He once just said to me that there's no such thing as psychology. Don't think about disciplines. They don't exist in coherent ways. No such thing. And I really think that's true of philosophy too. And indeed all disciplines. Okay, so coming to the end, I want to say there are really good examples of this. So this is Katerina's book, which I think is maybe an exemplar of what I mean by philosophically informed mathematical cognition research. Although, and then she is winning the prize, winning the Lakatos Prize the other day. Although even there, you notice that she positions philosophical outside of cognitive. They're two different things. Where I would want to claim that if this interdisciplinary field is going to work, they should philosophy should be contributing to cognitive science in a restructuring way. Okay, to summarize then, I think there's been this genuine interdisciplinary restructuring in the last 20 years, but philosophy has been largely excluded or excluded itself. That's very strange. It's a shame for two reasons. It's a shame because philosophers do interesting things, and I think it's a shame because it means there's been a lot of this big progress that's happened in mathematical cognition philosophers have not benefited from. If that's going to change, then some things need to happen. We need more infrastructure, and we'd have some of that already. But obviously, we need to really bottom out this goal difference issue. And if it's the case that actually philosophers don't share that goal, then fine. And then we also need to work out why Benedict-style bridge building seems to be preferred that compared to what I'm going to call mathematical cognition style restructuring. So the overall summary of my talk is, please come to the next conference.
Where is it?
Washington, DC.
Oh,
okay, thank you.
So just to comment first, so about in maths education, disciplinary essentialism, and that we don't get comments along the lines of this is not maths education anymore. I think that does still exist. It depends on what you write. I still get those. They're usually along the lines of from sort of qualitative purists who think that the types of tasks or questions I might ask can't tell you what students really think. What they want is some sort of in-depth interview. So there's often no answer in those. My question is about your about this issue of mathematical cognition over here and philosophy over here, and you see, I didn't go to the TLS last week, and that was primarily because when I looked at the program, it was almost all, it seemed to me to be almost all things on very basic number, or things like social issues, or things like dyscalculia in very young children. Whereas I am here because I perceive, rightly or wrongly, that the philosophers are more interested in sort of expert mathematical practice, which is closer to the research that I do. And there's a good sort of 15 years of educational, of learning in between those two things for most people in schools. And I just wonder whether you think it might be that, and whether mathematical cognition really means numerical cognition.
Right. So for the people online, Lara had two questions there. She got a point and a question. The point was that she thinks that there is still some essentializing in education, but it's primarily methodological rather than content. Yeah, it might be true. I mean, I think that's just an issue with social sciences. Some bad reviewers aren't very good at coping with methods that they don't themselves use. Yeah. I think that's a slightly different. Methodological things are slightly different from content things, I think, or theoretical things, not completely, but a bit. And then the second question was, is it really the case that mathematical cognition research is different to numerical cognition research, and are mathematical cognition people interested in expertise or higher level mathematics? And I think, yes, explicitly they are. So I put up the example of Francesco's paper on expertise. He's done a whole series of neuro studies on what post-compulsory mathematics education does to brain structures. Stanislav Dehaene, I think, is doing a project not dissimilar to that at the moment. I think there was work at MCLS on algebra. There was work at MCLS on geometry, graph interpretation. But your overall impression is correct, but I think that's because people don't turn up to it. I don't think that's because it's not welcome in the community. I think it explicitly is welcome, and people do it. And Francesco is an example.
Let us sort of try to short question, short answer.
Yeah, I mean, I say more during my talk, but thank you very much. But I want to take this occasion to, since we are in cognitive science, more experimental philosophy, but going back to the drawing, the diagram of Gardner, because there's been all this discussion after Nunez's publication about where cognitive science is going now. I don't know if you know about it. And basically, he was saying that lots of things now are on the neuroscience side, and there are much less of behavioral psychology. And so I just wanted to know what you think about it, because there was a lot of discussion in my department about that.
Yes.
Where it's going? It is still really what is happening now.
Yeah. So Verby's question was whether the Gardner diagram is still an accurate description of cognitive science, because there's more neuroscience now and less behavioural psychology. I think that's definitely got to be true, because the equipment required to do neuroscience is becoming cheaper, so more people can do it. So I think that it's perfectly fine for the balance between these various disciplines that have been restructured is going to shift over time because of all sorts of sociological factors. But I think the key test is the discipline still welcome in that community? Is it true that experimental psychologists are still welcome at cognitive science events? And yeah, absolutely they are. And that's got to be true of all of those disciplines, I think. Yeah.
Thanks a lot. I agree with everything you say. I just want to add another perspective on the reasons for this, and this coming from a philosophical perspective, philosophers here. One, I mean, you mentioned that there's always been a strong connection between mathematics and philosophy. Yes, if you think about Plato and Kant and so on, but philosophy of mathematics itself is a tiny subject in philosophy. If you go to meetings of the American Philosophical Associations, there are years with almost no talk on philosophy. And then so that tiny community then in the past 20 years has almost been split into the PNP and the traditional one. So that makes it even tinier. So in a sense, there are much fewer people in the sense to draw on, I think, in the first place. And one thing, if you look at, say, philosophy, another thing is, if you look at philosophy of science, but I think philosophy of mathematics often does what philosophy of science does, but like 50 years later. And one thing that happened there is that people in philosophy of science at some point also realized, the philosophers of science are talking about these big metaphysical, philosophical questions that have nothing to do with science itself. And then there was this development towards kind of history of philosophy of science. And now there are universities which have a philosophy department and a history and philosophy of science department. Right? So that you see already that there's this. It wasn't integrated into philosophy, but it has been split. I think the development of the PNP is similar to that, except that the numbers are much smaller. So they wouldn't. I'm not sure whether they won't be a department of philosophy and mathematical practice. And then I think also one thing that is that it might explain that it's kind of institutionalized, or the education. Philosophers are trained to be individualistic, right? Single author papers are by far the norm, right? And even though, yes, people claim interdisciplinarity is a thing, the fact that I published together with other people in journals that are not philosophy journals, that was raised as a critique for my recent promotion. So, if a young philosopher comes to me and asks me for my advice, for my experience, I tell them, yes, do the work that you're interested in, but if you want to advance in the career, publish philosophy papers in philosophy journals. Don't do this other stuff. So there's this pressure that when it comes to the outside. And then I think philosophers also have just a bad reputation among a lot of others. I was, a month ago, I had a quantum workshop. There's a research group in Bergen where cognitive scientists, linguists, and anthropologists get together. And yes, and it's about the development of quantifications and numbers and things. It's very similar things to here. And they were saying, "Ooh, this is the first time the philosopher is around." And then after I gave my talk, and then I had people come and say, "Oh, for a philosophy talk, I really understood everything. I was surprised about it." So, and even here, being a philosopher has sometimes this, you have to say, I'm sorry. And in fact, as you showed, it's because it goes both ways, right? Because we also show that people here do not go to the philosophy to this conference. So I think it has this kind of institutional pressures, and that is very hard to overcome.
Okay, so for people online, let me summarize Dirk's comment. He started off by saying he agreed with everything I said. That's a good start. No, so he said I may be underestimating how small the philosophy of mathematics is as a community, and then he said that various other things, but including that there's some particular practices in philosophy that might particularly mitigate against this, and in particular that he wrote a paper with some other people. I think you're referring to me, maybe. Was that the example?
No,
Other people too. And that was the reason he didn't get promoted recently. So I do apologise for that, though. Yeah, no, I agree. So there are issues about interdisciplinarity that need to be overcome. But my point is they can be, and I think the example of education and psychology is an example of that happening. So it's not impossible, but I'm not saying that they're not issues about, disciplinary identity. There certainly are, but it's not impossible. And if people want it to happen, it can happen. But,
I think that dinner was.
Thanks, I love it, and I agree. I guess you've already convinced me that we need to do this stuff, and my work now does include a lot of business education work and psychology stuff. PhD students here, 2 years working somewhere where I think the intersection is. I think I agree with you that the challenge is the startup costs of learning all this stuff, because to do philosophy of mathematics, almost all the people that do this seriously have a philosophy background and a mathematics background, and that's already learning two disciplines where most people just learn one, right? And so coming into education, there's a lot of education literature to read, and then psychology really is its own set of norms to learn on top of that, right? And so getting from 2 to 3 disciplines is already hard, and getting to a 4 or maybe 5, right? It's just really tough, right? Because there are plenty of philosophers doing experimental philosophy, and they're really philosophers that are learning one extra discipline. I think you just with every extra discipline you have to learn, you're narrowing down the number of people that have time.
Yeah, but Fenner is saying, he also started off by saying he agrees with it, so that's good. But no, Fenner was saying, for people online, Fenner was saying, look, it's really hard to be a philosopher of mathematics because you've got to learn philosophy and you've got to learn mathematics. Well, how is it reasonable to expect people to learn education, psychology, and all these other disciplines as well? And the answer to that, Fenner, is you need to have some collaborators. You do, fine. But that interacts with what Dirk was saying about there's this weird tendency in philosophy to be suspicious of collaborators, right? But obviously, if you want to learn 7 disciplines on your own, that's going to be hard work. But the fun part of research is collaboration, it seems to me. I don't understand why philosophers take that view. So yeah, absolutely, I agree with that, but it's easily overcome.
Don't you think the collaboration model is more the bridge building?
No, because it's the work that's being categorized. It's not That is exactly what I want to get away from. You shouldn't be categorizing individuals into disciplines. You should be categorizing work.
So we have to be, Keith.
Oh, okay, I'll be quick. I want to contextualize Sylvia's comment about your work. So, for those who don't know, about 2 weeks before, Pablo Ramos had a very nice explanation conference linking mathematics education and philosophy approaches to education. When Pablo presented, so there were 4 philosophers and 4 math educators. When Pablo presented his work, he situated himself as a mathematics educator. And there are reasons for this. I'm not saying it's the best specification. He talked about the ESM paper and so on. But this, if you're wondering why Sylvia or others might be saying that this is a math education project, that was actually self-identified by Wayne Thor.
So he got it wrong. No, I'm serious though, right? I mean, if you're saying that Pablo's answer to that question is, yeah, of course it's maths education. I think I don't believe you.
No, he didn't say that, but there were 4 speakers for math education, 4 for philosophy. He was not a philosophy speaker. He was there representing math education points of view.
Yeah, what I want you to get away from is stop using that phrase. There's a maths education speaker and a philosophy speaker. I don't
use that phrase.
Hey? Oh, well, I want him to stop using that phrase then. I don't care who uses it. I want that phrase. I don't think it's a helpful phrase. It's the work that should be categorized, not the individual. No?
So yeah, thank you. I think this was really interesting. So I want to just clarify a few things. So first of all, I'm not committed to what you call Fields essentialism.
Okay.
But I think it's actually helpful to characterize even people in this way. And this is related to something we were talking with Keith yesterday. It's just about also the background knowledge. I don't know a lot of math education or psychology literature. I know the philosophy literature, and that's probably vice versa for you. It's already hard, as was pointed out, to read the math and philosophy. So I just don't have that type of expertise. And
can I just respond to that first? Because I don't know, is that you're on the same point?
No,
Okay.
yeah, on the same point.
Okay.
And I understand that. So I see that a lot of people coming from the normally publishing math education journals are now publishing in philosophy journal. Like Keith also has a great papers recent on rigor in Philosophia Mathematica. You have like papers in syntax, etc. But I think even more, if we want to go in that space of overlap, we have to be very careful on not talking past each other. And I think, so what the main moral of my talk yesterday was that sometimes actually we do talk past each other. And I think even your example today about the group presentations, I don't think it's so straightforward as you put it. Like, I would say those are different things, or it depends on the context. Like, I don't know, I don't have enough information. So I just think it's a very difficult thing. And just like last comment also on their point, so I think there's a big difference also between philosophical culture in Europe and North America. So I've been educated in North America, not just coming to Europe, and I think in Europe it's much more common and accepted co-authorships. I was criticized when I was getting jobs in Europe because I didn't have enough co-authorships, for instance. I mean, it's crazy. I found it crazy. But like one thing that I'm really committed to in my work within philosophy of mathematical practice is to show that it's really philosophy, because that is the main objection from North American philosophy department. As Dick was saying, they want to put us in the HPS groups because they're saying we are not mainstream enough. So actually, also that is in some sense like part of interdisciplinary work we have to do to kind of connect more our work to core philosophical issues if we want to be part of that debate. That's also up to us and our individual interests. But I'm just saying it's not an easy thing both ways, let's say, like to integrate ourselves in the philosophy and also in other disciplines.
So Sylvia made several helpful points there. The first one was that it is useful to characterize individuals as being from disciplines, not the work, as I claim, because she wants to, she makes the point that people have different knowledge backgrounds and she knows the philosophy literature. I mean, I deny that. You can't possibly know the whole philosophy literature.
No,
right? So that categorization
I
is...
definitely don't know a lot of the education literature. Yasin is one example who maybe knows both things.
Okay.
And he can tell you how hard it is.
Yeah. No, sure. But so I'm absolutely not saying that the knowledge resources of your collaborators are irrelevant. I'm saying that operationalizing that by saying which discipline they're from is hopeless. You know, I have collaborators who have expertise in structural equation modeling, which I don't have, but we can't deduce that from saying we're both psychologists. I mean, this is just a rubbish way of operationalizing knowledge differences. So I agree, knowledge differences are important, but you know, I don't want to know that you know the philosophy literature because I don't believe you. I want to know what bits of the philosophy literature you're an expert in and how, you know, so that the main point I agree with, but the operationalization I don't agree with. The second point was about, what was the second point, Sylvia? Oh, the
use
North.
of the terms, or
Use the
I guess
terms.
I can
Yeah, yeah.
analyze the methods.
Yeah. So that's clearly right. Yeah, I mean, but that helps. Collaboration helps there because I think if people work together, then clarification comes much more quickly than if it gets battered about in journal situations.
I agree, especially from people embedded in different communities.
Yeah.
But that's
Well, no. I mean, again, I don't know.
just
I mean, that's true in all communities. If all people embedded in the same community, people have different understandings of words. That's just a standard working
if
together.
they're in the same literature.
Even no one reads the same literature.
I mean, like,
Philosophers do.
I don't believe you.
No, can I follow up on
Hang on, let me. Yeah, go on.
No,
Sorry.
because I think that the point of terminology is very important.
Yep.
I remember when I wrote the paper with Marinella Cattivetti, it was in London, on recognition. It was really introductory things for philosophers. And so she asked me to help her. She said, I'm not sure who I'm targeting. So we're talking about 2006. And it was funny that, for example, she was using number meaning, number concept as totally synonymous, and everything was processing. And for me, my role was to say, look, we are writing to philosophers, so we should be very, very careful about the terms. But it was not a problem for her, and I see why she wasn't distinguishing between. But this is the kind of, just to give an example of why all this terminological, it seems terminological, but it's more than that word.
So
It's needed.
yeah. Okay. So,
explanation.
but I mean, that's one of the reasons I really think it's important that philosophers are involved in this new interdisciplinary field, if I'm right, because philosophers are particularly good at pointing out subtle incoherences in concepts, right? So I wouldn't say, oh, you need to be really clear to talking when you talk to philosophers about what you mean. No, we should all be really clear what we mean all the time. And philosophers help us do that because you're particularly skilled at that endeavor, right? So I would phrase it like that, I think. Yeah, I want to get back to this Sylvia's point about North Americans don't like collaborators and Europeans do. And that's important if you want to be, and she cares a lot about North American philosophers thinking what she does is philosophy. Is that a fair summary?
No, I mean, like, I feel that it's a task for a lot of philosopher of mathematical practice to integrate themselves into their analytic philosophy discussions. Many of them don't care at all. So I think a lot of people working within PMP don't care about that type of analytic philosophy, but some care, like I care. So I think, like, for me, it's already difficult.
Okay, so Sylvia's saying she cares a lot about being accepted by analytical philosophers, particularly in North America, and that's the problem in the way
I mean, like,
I guess my response to that is I don't think you should care. I think you should just you should be confident in your work. It's interesting and important. That should be enough. And if other people don't recognise that, I regard that as their problem, not your problem. There will be enough people in the world who do recognise that you do important, good work. No? Okay.
No, I mean, I just think it's difficult, and I think it's also exciting to be part of the broader debate and to show how mathematics, and in particular mathematical practice, can actually be a significant case to shed light on broader epistemological issues that are interesting on their own.
Well, I mean,
I'm like kind of bothered by this slide because I would say, like, I'm not answering. I'm not saying that it's not philosophy, that paper. I actually was talking about a different paper, which was also in a philosophy journal, who just changed name, unfortunately, from Axiomatis to Global Philosophy. But that paper clearly is experimental philosophy, but it's about experiments, and I pointed out the things I thought were difficult to accept.
But that paper.
So I'm not saying.
So Sylvia was complaining about my bold font here, saying that she was talking about a different paper. I mean, I understand you were talking about the Aximates paper, but the Aximates paper was in a test of this account, right? So this account was. So I think if you're saying it's a, I don't think you could be defining substantive content differences by methods.
Benedict thinks so.
Well, Benedict does think so, but I really think that's a very peculiar worldview. Yeah. Sorry, we're really over.
Sure, I think we have to close. It's interesting.
Thanks, everybody. Okay, everybody. So everyone's ignoring me in the room. We need to move straight on. There's no breaks. So the next speaker is Yassine. I'm going to sort of waffle for a bit until a couple of people come back into the room.
That's okay.
My attempt to get the next talk started has led to more people leaving the room, not less. So,
yeah, the bonus is that we start at 11:30 for Valeria. That's the only constraint.
Okay, we'll give it 2 minutes because a couple of extra people have just left.
Yeah, you can take them here. This is water and this is.
She was online. Okay, I do think we need to get started, otherwise we're going to run out of time. So, very pleased that Yassine is giving his talk. Over to him.
Okay, thank you. So, in this talk, I mainly want to launch a discussion on a question I don't know how to answer it myself. And the question is this one: is that should learning be an object of study for the philosophy of mathematics? And the situation is very strange because on the one hand, you would think that learning is the paradigmatic epistemological notion. So if you think of learning as acquisitions of skills, knowledge, and understanding, then clearly learning should be studied by epistemology, by the theory of knowledge. And this is what philosophy has been doing for more than 2,000 years. But on the other hand, if you look to contemporary philosophy of mathematics and even contemporary philosophy, epistemology, there is very little mention of learning, and they really take it as being not at all their concerns. But the situation is changing with this like practice turn in the philosophy of mathematics. So here you see again the notion of learning popping up here and there. So the question is, okay, so what should we do about that? So if learning is important for what these philosophers want to do, how to move on, what are the questions, and then more importantly, what relations are we going to have with mathematics educators who are the experts on this topic? So probably they should answer these questions. So you see that I think I realized what I wanted to do with this talk as soon as the talk was done somehow, and I think that I'm kind of so building an argument that learning is important. And I think that this contributes to the discussions that Matthew led, because we talk about human mathematical functioning, and it seems like there's a discussion on whether this is important for philosophy. So I think you can interpret some of the things I'm going to say by finding an argument by saying that, okay, philosophers care a lot about these things, and I will show that if they care a lot about these things, they should care about this human mathematical function. So, okay. So I cannot talk about learning and philosophy without going back to Plato. So I imagine that you've all heard about the Meno. Do math educators know about the Meno? So the Meno is this famous dialogue because here you have Socrates and a slave, and they engage in the dialogue. And what Socrates wants to do is to show that the slave can somehow by itself figure out some solutions to some geometric problems and get some geometric knowledge. Maybe what you don't know is the context of this discussion. So in the Meno, this is a short dialogue, but it talks about a lot of different things. Actually, what it talks about is what is virtue, what is a natural virtue. Can virtue be taught? And whether the soul is immortal. And believe it or not, all these things are connected to mathematical learning and teaching in the Meno. So I think if you're mathematicians and you're going to write a grant, I think this is the type of motivation to put. Because if you said, okay, if whatever I'm doing can say something about the immortality of the soul and the natural virtue, I think it's hard to beat as motivations, right? Okay, so why are these two things connected? So in the Meno, you have Meno and Socrates, and they say, okay, we have to figure out what a virtue is. And Meno says, but okay, so we're going to do some physical inquiry, but the problem is that presumably we don't know what virtue is at this point. So even if we hit the right answer, how are we going to be able to recognize that this is the right answer, given that we don't know what virtue is? And Socrates is going to answer that by saying that, look, there's another way we could get knowledge. It's because somehow what virtue is already within oneself, within ourselves, and we have to somehow remember or recollect it. And the dialogue on mathematics is there to give some kind of an examples or proof that this is possible. So you can get knowledge from within somehow. And so this concerns a certain type of knowledge in Plato's theory of knowledge. It concerns mathematics, but it concerns also ethics and all these Platonic ideas. So I think it has to do with a priori truths. That's how it is connected. So for the fun, just to remember it, what the problem is. So here's a smaller example of the dialogue where he said the problem. So then he talked a bit with the slave. And then Socrates asked the slave, so then how many are 2 times 2 square feet? And the slave said 4, Socrates. Now, so the question, might there be another area double this one, but of the same shape, with all its lines equal, just like this one? So the question is, here we have the square with 2 feet sides. It has a 4 feet square. Can we have another square with double the area? And the slave say yes. So how many square feet will it be? 8. And now comes the problems. Come on then, try to tell me how long each of its lines will be. For this one's line were 2 feet. What about the line of that double area? So basically what we want to do is that we have a square and we want to build another square which has a double area of this one. And so the dialogue goes on, and then the first answer that the slave gives is, Well, I think it should be, the size should be like 4 square here. And then they draw on the sound, I guess, something like that. And then Socrates leads the slave to kind of count, and then he realizes that, oh, no, this is a 16 square feet, and actually we want 8, so that doesn't work. So let's say, okay, so it must be between 4 and 2, so let's try 3. So you give that, and again, they do this counting, and they say, oh, no, this is 9, so this doesn't work either. In each case, the slave recognizes that the answer is not good. Then, of course, Socrates helps a bit, and he kind of put the slave along this trajectory and say, okay, now let's look at the diagonal. And then they are counting, and then they realize that, okay, this is indeed a twice the square. Okay, what's the point of all that? So if you look in the menu, all these arguments that clearly has to do with learning mathematics and teaching plays a key role into an argument for Plato's theory of knowledge. So first you have to say what the lessons of these things are. So the first observation is that after a series of wrong answers, the slave reaches the right answer that he recognizes as correct. But the whole point of Socrates, or Plato through Socrates, is that Socrates claims that he has done nothing more than asking questions. So if the slave got this knowledge, it is not because Socrates told him. The knowledge was there, and the question was just to guide him to reach this knowledge. So this is called Plato's theory of recollections. This is really key to Plato's theory of knowledge. And the idea is that for Plato, learning is a special kind of recollecting or remembering. And I think that this resonates nicely with some kind of a view in mathematications, because Socrates really reject at all the teaching by telling. He really doesn't like that. So it's not at all his conception of teaching. And the reason it's not his conception of teaching is because he has also a different conception of learning, is that learning somehow has to come from the individual. So the knowledge cannot come from the outside, it comes from within. So you have to reveal this knowledge. So that's what I said, knowledge comes from within oneself and is already there. This is why this is an argument for the immortality of the soul, because for Plato, actually what happens is that your soul had previous life and you know about that before, but unfortunately you forget everything. So now you have to remember. And so the fact that it's already there is an argument that somehow the soul lives other lives before. So it's, the notion of teaching and Socratic teaching is very interesting here, because so you see that you have to teach the students without telling him anything about the content that you are interested in. So teaching is really a form of guiding the recollection process. So method is similar to a prior truth. So this works for mathematics, but it's also work for can be extended to all of mathematics and ethics. So here you see that some kind of the starting of philosophy, like learning, is not something that philosophers can say, okay, I don't care. It's really at the heart of Plato's theory of knowledge. But unfortunately, if you move to contemporary philosophy, that's not the case anymore. So I want to talk a bit about epistemology. So this is analytic epistemology. So this is a field that talks about knowledge, analytic philosophy. And to show you that there is little about learning, about transmission of knowledge, I want to show the introduction of this book. So this is John Greco. This is a leading epistemologist. And he wrote a book not long ago, 2020, called The Transmission of Knowledge. So Keith told me that you should not talk about transmission of knowledge with mass educators. They do. So that's already interesting things you can learn from each other. So John Greco presents that as if it was some kind of a revolution that we're going to talk about transmitting knowledge from one to the other, and so about learning. And this is what he said at the beginning. He said that the phenomenon of knowledge transmissions has gone largely unrecognized in epistemology. The lack of recognitions come in two varieties. First, most of the epistemological traditions has been entirely oblivious to the phenomenon. It is not implausible that traditional epistemology has been concerned with the generation of knowledge, rather than the transmission of knowledge. And this is already the idea that, okay, what is really important is how knowledge is generated, that you can get knowledge from one individual to the other. This is some kind of the secondary questions. And then he said the second variety of recognitions characterizes more recent epistemology. Contemporary authors have indeed shown interest in the transmission of knowledge, but the discussions have been grappling and often starting. One cause of distortion is that many authors think that all testimonial knowledge involves knowledge transmission. Accordingly, they try to give a general epistemology of testimony rather than epistemology of knowledge transmission. So this concerns the subfield of epistemology, which is social epistemology. So social epistemology has talked a lot about testimonial knowledge. And so Greco wants to say that okay, there is more to the question and in the proper account of knowledge transmissions. Interestingly, in this book, you have a chapter on education and understanding. So I think that this is also revealing. So at least from the core of analytic philosophy, some people that think that this is important, and I think that from there you can easily go to education. I think that education is physically important for the core of philosophy and analytic philosophy. If you go to analytic philosophy of mathematics, what we may call mainstream philosophy of mathematics, there's really not much. So these are two handbooks that have appeared, and you won't see much on learning there. So basically, if you look at 20th century philosophy of mathematics, what you have is mostly work on foundations of mathematics. And then in the second half of the 20th century, you have a lot of work on the metaphysics of objects, how we can know things about them. And you see little about learning there. You see a bit in structuralisms, because structuralism is the idea that mathematics called objects are positions in structures, and so we have to explain how you can learn things about structures. And you see that well, they go into they need this learning there for their epistemology to take off the ground. But now, if you go to the philosophy of mathematical practice, the situation is a bit different, and we see learning popping up again. And I think a good example. So this is some kind of anticipation of mathematical practice. This is a book of Philip Kitcher on the nature of mathematical knowledge. This is in 1984. And this is what Kitcher writes at the beginning. He said that the theory of mathematical knowledge, which I shall propose, break with traditions, not only by rejecting mathematical empiricism, so this we don't care. I shall also abandon the tacit assumptions which pervade much thinking about knowledge in general, and mathematical knowledge in particular. We are inclined to forget that no words from a community, painting a picture of a person as having built up by yourself the antibody of a knowledge of, for example, mathematics. This is really the traditional view that you have in Kant, that you have in Frege, that you have in others, that basically, like, when you have to account for physical knowledge, you can do that everything from the individual's perspective. Doesn't have to take into account the social context. It doesn't have to take into account interactions with others. And then Kitcher said, yes, it is a commonplace that we learn mathematics from others. Traditional view of mathematical knowledge will probably not deny the commonplace, but will question its epistemological relevance. This is really the heart of the question. But is this epistemologically relevant or not? And Kitcher said, well, I shall give it a certain place in my account of mathematical knowledge. So what is this account, if you don't know it? So the idea is that this is an evolutionary theory of mathematical knowledge. So you want to explain the knowledge that we have now by somehow explaining how we get there from other people's knowledge in the history of mathematics, starting from some of elementary knowledge. So you think of like the development of mathematics, you start from the most elementary mathematics, and then you explain all the rational transitions you get from one practice to the other, from more and more sophisticated mathematics to the knowledge that you have now. And if you do that, learning matters at two places, because first you have to explain what's going on at the beginning. So you have to explain how your epistemology can take off the ground. So we don't know, at some point, probably humans didn't know anything about mathematics, but they started to know something about natural numbers, for instance. You have to explain this starting point. And this learning is important, and you will see that Kitcher talked about it there. And you also have to talk about learning when you move from one practice to the other, because of course, if you're in a given generation, then you learn from the previous generation who have learned from the previous generation. So if you adopt this kind of dynamic view of the growth of mathematical knowledge, and that this is really your theory of what mathematical knowledge is, then you have to assess with the learning process. So I want to read this quote, but so for Kitcher, the beginning is an empiricist conception. So Kitcher thinks that mathematical knowledge takes off the ground because we are some kind of interacting with the external world. So, for instance, we interact with objects, and we have several objects. We collect them into sets. We can add them. We can make union and stuff like that. So, we really believe that the elementary mathematical knowledge, it starts from there for like interacting with the world. This is why I think that this is an empiricist conception of mathematical knowledge, because it's not a priori. It does have a root into interaction with the world. And so when you try to build this part of the theory, that you start to talk about children learning things. And this happens at all places in mathematics. I said, children come to learn the meaning of sets, number addition, and to accept basic truths of arithmetic by engaging in activities of collecting and segregating, and then so on and so forth. So what I want to say here is that if this is really the theory, then the philosophers have to say what he thinks learning is, because this is really important for what he cares, namely providing an account of mathematical knowledge. This is the same thing that for Plato, that you, if this is really your theory and that learning plays a key role in your theory, then you have to say what learning is. And maybe there are several ways of saying what learning is. Maybe some of them are not compatible with your general framework. Maybe some of them are just not true empirically. So here you see that if you go around this world, that I think that learning is no doubt something that philosophers should care about. Here's another example, more recent. So this is Jose Ferreros. And it's the same same idea of an evolutionary theory of mathematical knowledge. So it's called mathematical knowledge and the interplay of practices. This is really some kind of paradigmatic of certain traditions within APMP. And so here, it's not like teacher where it thinks really about rational transitions. Here is much more like interconnection between practices. But what is interesting is how he described the project at the beginning, what he wants to do. And he says the following: he said that I will intentionally not adopt the position that only resource mathematicians do mathematics properly, and you should be interested in how individuals attain knowledge of mathematics. Doing research and developing new mathematics is certainly of enormous interest, but you are interested also in how aspiring members of the community learn to do math and mathematical research, how they obtain their professional know-how. Those who are interested in the educational level, which is centered not on novel productions, but rather on the reproduction of mathematics in developing knowledge and among students, and the reproduction of the community of mathematicians. So here you have a philosophy of mathematical practice that tells you explicitly that learning is important for his philosophy of mathematics, and moreover that education is important for his philosophy of mathematics, right? So again, here you see that there are really people who believe that this is philosophy, and philosophy should care. So an interesting fact, so you see that Ferreros talk a lot about community of learners. We'll see again after. Here there is an obvious connection to Wenger's work on the community of practices. In the philosopher here, who knows Wenger, community of practices? So for the philosopher, no one is raising hand. For the education people, everyone knows, right? It's exactly the same stuff. I mean, I'm sorry to say that, but it's crazy. So here's how Ferreros described his what you consider practice. By practice in general, I mean a recognizable type of activity that is done and can be taught and learned by human agents. So you see that in the definition itself, you have teaching and learning. So this must be important. And of course, this is connected to all this community of practitioners. So he said the community is most relevant to individuals' attainment of proficiency. If you want to learn how to dance, how to sail a yacht, you become an apprentice to those who already know. And like I was saying, in mathematics education, there is a huge literature on that, almost framed in these terms. So how learning is playing in Ferreros' book. So just to illustrate to you that so this is something that is interesting to promote. And it also actually plays a role. So one thing that is really nice is that is making a parallel between the development of mathematics and the process of learning. So the idea that like mathematics develop in a certain way, that you start from the elementary mathematics, numbers, geometry, and then you move to more sophisticated things, your analysis, vector spaces, topological spaces, categories, whatever you want. And I think that there must be some kind of parallel between the way these things develop in the history and the way they should be learned. So he said the process of learning must present, again, some of the crucial ingredients that determine the growth and the current configuration of the mathematical edifice. So here you have a nice bridge again, because you can say, oh, I can try to design my teaching and think of the learning by taking inspiration from the history of mathematics. But you can also think the other way around. Like if you're really interested to analyze these transitions, you may look at what people have said about learning and maybe use that as inspirations for your history of mathematics. Of course, this is connected to what Lakatos have been doing, because he provided a rational analysis of historical developments within educational settings. So there's a link of this sort. And he also talked about learning in terms of conceptual understanding and the advancement thereof. So this is again the same idea, is that so you want to explain how mathematics can progress by advancing understanding, and say that if you want to do that, it's also interesting to look at what's happening in the individual when he gains understanding of certain form of mathematical development. Okay, so this is one motivation is this: if you adopt this evolutionary theory of mathematical knowledge, that it seems that you really have to care about learning. But I think that you also have to care about learning if you talk about expertise. So here I want to use the work of Valeria and Sylvia, who are there, and then they can give their opinions about that. But I think that's their work illustrates what learning is a philosophical notion. So what they want to do here is that, this is a type of work that people do in the philosophy of mathematical practice. They have an advanced practice. For instance, here they have interested into dialectic thinking. So they are studying proofs in low-dimensional topology. So this is kind of an advanced field. When the some transformations are described by a diagram. So they want to understand how is this working, how does this function within the proof, what sort of capacities are involved. And here is their theory of their account. So they said, we will propose that reasoning in low-dimensional topology is based on pre-existing cognitive capacity. So you first have, first element of the account is what the cognitive build-up that you already have. Mathematicians imagine a series of possible manipulations on the function they use. And is modulated by, and the second point is that N is modulated by expertise. So I said representations are cognitive tools whose function is depends in part from pre-existing cognitive abilities and in part from specific training. So here I think we are coming back to one central point that we saw also in this workshop, and I think Keith mentioning is that, and I think Lara in her question mentioned that we are interested in investigating expert systems. So the thing we are after is how do experts function. So if you are even a student in a topology course or research mathematicians, you have to analyze experts. But what are experts? Well, experts are people who didn't know anything, get the expertise and become experts. So for me, I think there is no way out of, if you want to explain what the expert is, you have to explain the path that gets from the non-experts to the experts. And this is exactly what you see here. So you say, on the one hand, you have to explain what are the cognitive capacities involved. And then on the other hand, if you want to account for an expert system, for instance, what does the agents or the subject that does the transformation do, then you have to involve the training. And I would say that if this is your epistemology, this is what you care about, then you have to tell what the training is, and you have to tell how it transforms the agents into an expert. And actually, this is directly connected to things that philosophers care for sure, because in Sylvia and Dahlia's work, this is used to make an argument about the nature of rigor and validity. So here you cannot be more philosophical, because rigor and validity, this is about checking proofs, this is about justifications, and this is about knowledge, right? So knowledge mathematics, good deal of the knowledge mathematics we have is based on proofs. So you have to say, what is a proof? What do you do with a proof to get the knowledge? Well, you have to check the proof and do some sort of things, inferences and reasoning and such a thing. So your theory of reasoning, your theory of what you do here is really an additional part of your theory of justification and it's a part of the theory of mathematical knowledge. And so if you're in your theory of what you do in the reasoning, you have an expert agent and you say, I'm going to account for the expert agents by telling you that it is trained and there is a specific processes that gets these agents, then I think that you have to say what this training is, because this is an inherent part of the model of what the agent is at the end. So here I said, in review, what first and refers to as good human processes for checking. These are context-dependent processes that in low-dimensional topology rely on manipulative imagination. So this is the term they coined. And not generally on intuition of dimensional space, duly trained according to specific practice. So even if you want to know whether this is correct, whether this functions the way it does, you will have to say, okay, so I want to know my system. What is the system doing that? System that has been trained. Okay, so how does it been trained so that I can understand what the system is? And actually, I had the exact same problem in my own work all the time. So I'm putting that, actually, that's the motivation, is that the way I want to do things, I keep popping up into this learning process. So this is somehow the same problem as we just discussed. So I wanted to say, to work on rigor, and I want to say what a rigorous proof is in practice. So how do people judge a rigorous proof in practice? And I said, okay, how can you do that? Well, I think you have to say, so if you have a proof and you have a guide, nothing is happening, right? So you can look at the proof, nothing's happening. You have to tell what the process is being done. And so you have an agent, it takes the proof as an input, it does something, and then you say rigorous, non-rigorous. So, okay, so very good. So this means that if you want to characterize what a proof is rigorous, you have to think of it as the output of a system doing something. And so we have to characterize this verification process. So this is what I've done. So I have to characterize the verification process. But this verification process, it is done by an expert agent. So I not only have to say what the process is, I have to say what is the agent who is doing the process, what are the skills, the resources that the agent has to do the process. So you need to characterize both. And so I take that seriously. And this is why I won't detail that, but in my paper, I say, okay, so I'm going to introduce a training model. So I have an agent. So here, this is a model. I won't go into all details, but basically I have a simple agent with knowledge and rules. So he answers propositions. He has rules I can apply to propositions. And then he starts with a basic situations, and then you can learn new knowledge, you can learn new rules. So I've tried to describe how all this could work. And actually, I was inspired by Sander McLean, so who I mentioned earlier with the important mathematicians, but at the beginning of his career, he was working on logic. And so he was doing stuff like that. And then so he was talking about how you can have an agent who can verify inferences at a glance by coming up with more and more some sort of more general rules of inference. And he said, so in general, when a group of elementary processes, so this is inferences of proofs occur repeatedly in the course of many proofs, it is able to formulate this group of steps once for all as a new process. Much of the ordinary education in mathematics consists in training students to recognize such processes at a glance and as well as composites. So I showed that to show you that here clearly, if you're in the project of kind of logical project on trying to provide a theory of reasoning, and then you have you want to kind of have this theory to account for what's happening in the practice, and at some point to kind of force of telling, okay, how is your agent trained? How does it get better? And you have to, if you want to explain what's the structure of your agents with the expert at the end of the training process, then you have to you come back easily to education and learning issues. And so, of course, this creates problems because so now you are someone like me, and of course, I'm not an expert on learning. And I say, okay, I need it, so I play the game. I say, I'm going to tell you what I think the training model is. I don't need to cover all possible aspects of teaching and learning, but I need sums for my whole stuff to work. And actually, at the end of the day, this whole stuff is philosophically, at least philosophers should care, because they are interested into the relations between informal proofs and formal proofs. And so in my story, these relations holds on into this verification process. And at the end of the day, the training part is key to the whole thing for functioning. Because somehow some of my argument for the relation between the two appeal to structure of this training model. So I don't need any aspect of the training of the learning to be right, but I need some aspects to be correct. And then this is really nice. I think that's okay. So I'm telling you what learning is in this context, or at least a small model of learning, very idealized for what I need. And then other people who know more about learning can just come to me and say, you're wrong. And I think this is a very healthy relationship. So Keith did that exactly. So what he did is that he exhibited some cases in recursion theory, compatibility theory, saying, okay, look, like in your case, your training model doesn't work. I don't think it works this way. So I think here we have a very healthy relationship, because then, of course, I can reply to that. So it's not because I'm not the expert that I don't have a say, right? So I can say also, and I can learn about that. But I also think of this as, I don't see the disciplinary boundary here. Is that I won't say Keith's argument is not receivable because he's a math educator. So I think, yeah, I admit that this is learning, that you know more about learning. Maybe some of them is not relevant, but that would be my charge to explain why what you're saying will not be relevant. This is not what I would like to do here. But at least this is an example where we can really bring educations to philosophy. So you see that in my talk, I wanted to do something that I don't think was too much covered, is what you mathematics educators can do for the philosophical practice. And I think here is an example of that. Okay, so now I can answer my question. So should learning be an object of study for the philosophy of mathematics? For the traditional metaphysical and ethical research agenda of the field, probably not. So if you're interested into the natural mathematical object, it's not yet clear that learning is important. Also, actually, I think it's again a trap because, like I say, so there is this famous Benacerraf problems that you might have heard, where you have to show that your metaphysics works nicely with your epistemology. And often in the epistemology, you see that people need learning. So for instance, like I was mentioning, the structuralist people who think that mathematics is all about structure, they have to explain how you can learn structure. And they gloss the story about children doing stuff. So this is funny as well, because the philosophers, they're super picky on stupid things. And then there's a big hole in the theory, and they are super happy with that. So they say, oh, learning should work like that. So it's really, learning is important for your whole stuff, right? If this doesn't work, your whole stuff doesn't work, right? So you have to tell what it is, but that's so you see that's kind of like people do whatever we want in this kind of things. Like if it doesn't suit them, they just say, yeah, it's not important for philosophy. So for the foundation of mathematics, I would say probably not either, but I'm not sure because if you think of foundation of mathematics, also in this development of interactive theorem proving, we saw it in Gila's presentation. So I totally agree with that. So there's probably a lot to learn between educations and this development in the foundation of mathematics. If you want to make a more user-friendly interactive theorem provers, you may need to do some kind of empirical studies, but the logicians and the computer scientists, they are really not equipped to do that. And I think that's what Gila is doing, is giving them a big favor because they don't know how to do that. They don't know how to collect data. They don't know how to answer empirical questions. But if you do, and then you say, okay, look, if you do it this way, it's much better than doing it this way, then you may have also an input. So. But what I would like to say is that for clinical practice, I think the answer is probably yes. I've tried to show you 3 examples. The first one is that if you want to develop something that looks like an evolutionary series of knowledge, where you think that history is important, that there are transitions, and that you expand the knowledge by this genealogy, so how it comes from, then you have learning popping up. If you are interested in accounting for agents who have expertise, which is acquired through training, then you have to specify that. I think this is the case for Sylvia and Valeria, which they showed, and it's the case for me, and I think it's also the case for the explanation people, because recognizing an explanation, I think we had the discussion yesterday, is also something that requires an expertise. So do you want to be able to explain in your philosophical account how an agent recognizes that something is explanatory? If you do, then you will have the same expertise problem. So what is this agent? What does the agent needs to know, needs to acquire to be able to recognize that something is an explanation? I think that's especially in Ellen Stowe, that was important. And if you follow the analytic epistemologist, and Celia made the connection. I'm also interested in the connections, Federer as well. But we can simply jump in analytic philosophy and say, okay, you're interested into you go to John Greco. This is presumably admitted as core analytic philosophy. You talk about transmission of knowledge, so you can come and say, okay, I'm going to talk about transmission. So you talk about transmission of knowledge, and I'm going to talk about transmission of knowledge. So this could be, even from the perspective of core analytic philosophy, a legitimate topic of study. So what can mass educators do for the philosophy of mathematics on these fronts? I think one thing they should do is push philosophers to specify their accounts of learning and training when the philosophical analysis require one. So I think that would be a good thing to do. So if they finally come to MCLS, that's a potential way to do things. If they actually propose something as I did, then they can critically assess it. So this is what Keith did with respect to some of my proposal, which I think is very healthy. And the much better thing is that they should contribute to philosophy. So philosophy is isolated because you could say the philosophers, they don't come to as a neuroscience, education conference, but then others can come also to the philosophy conference. Why not? Why is it just one directional thing, right? So you can all come to a PMP and then give talks. And some of you do, fortunately, so this is pretty cool. And so, for instance, you could say, I think something that would be very healthy, that's, okay, you take my account, or you take Valeria and Sylvia's account and say, okay, I'm the expert on training. I'm going to help you with that. I'm going to write a paper where I'm going to tell you how this training is acquired, how does it work. I'm going to provide empirical data. I'm going to connect it to other accounts of training and learning. And I think this would be, from this perspective, a direct contribution to philosophy, because this is something that needs to is connected to the big question that philosophers are interested in. Okay, thank you very much.
Okay, so questions.
Thank you so much. I think this is really great. So let me first start with a comment and then a question. So the comment is that I think you pointed out some of the stuff we discussed before about the terminology problem. Mm-hmm. So in your paper, also when you say transmission of knowledge, you said, oh, the math educator people don't want to talk about that. And in fact, I remember I gave you comments on that paper, and I gave you basically diametrically opposed comments compared to the comments by Keith or someone else, just because, again, like we had a different understanding of the literature. And so I think that's also like relevant for the previous discussion. And I was wondering when you looked at this zetetic epistemology movement. So Jane Friedman is very popular nowadays because she her big project is somehow to extend the norms of epistemology
No, I
to
know.
the norms of inquiry.
I know.
And she started saying, look, maybe these norms are
No, just
different or even intention or not. So it seems like totally in line with what you're doing here, and that is a.
Oh,
Yeah.
definitely. So actually, I've been working on inquiry in my master's thesis, even before it became a big thing in philosophy, epistemology. So I think inquiry is important. There's a world tradition from Jaakko Hintikka, putting inquiry in the center of. Hintikka has a book called Socratic Epistemology. It talks about that. So definitely agree with that. Yeah, this is a connection I miss. I'm sorry. I think we should really definitely look into that. There is also a connection with so the question stuff is very dynamic. So it's very dynamic also in semantics and pragmatics. About semantics of questions, and it's also connected to work in psychology of reasoning. So, for instance, Salvador Mascarenhas and what's his name, but and someone in Oxford, they work together like a view of a question-based reasoning as some form of kind of a question-based processes. I don't know much about. I don't think if this is important in Katarina's version, but definitely there is a connection there that should be explored further. And the second thing about the terminology, I think Keith can say so. I think so. Keith commented on what I said and said you should not talk about transmission of knowledge to educators because this resonates with knowledge by teaching, which is presumably bad. So is this a terminology problem? I don't know actually. So clearly they agree that people can acquire knowledge and at some point that knowledge get to them. So isn't it knowledge transmitted then? So I think it's
transmission of knowledge carries the baggage, and I could just tell you something and you want to
right.
Exactly,
yeah.
It's an active interpretation. It does bring up the drawback that math educators would be very quick to dismiss a paper that said transmission of knowledge rather than consider the ideas. I do think as a field, it's a vice that we get obsessed about terminology rather than the conceptual content of the ideas. I wasn't saying that we were right to be put off by the word transmission. I'm saying we've run into some headwinds.
Right, and I think that we could. Keith mentioning the reason why they don't like transmission of knowledge because like it's associated with some kind of theory of teaching, like teaching by telling or things like that are not do not have good press. But I think the phenomenon at the end of the day is the same. I think so. It's just like a matter. I think for here I would be. I don't think that this would be interesting. On the contrary, if this really how you conceive like knowledge. Maybe you can talk about knowledge acquisition. Would that be better? No, you don't know. Okay, so clearly, knowledge construction. Yeah, but this is very lauded. This is very lauded, right? Okay. So we're gonna make some poll. No, we're gonna make some poll and vote. We're gonna vote. That's how we do it. Co-construction. Other questions? Did I miss? No, nothing else. Other questions? Yeah, Stefano?
Yeah, I think I agree with all your big conclusions about the importance of learning. So I love this and I'm behind it. I wanted to ask you an epistemology question because I thought it was very funny you put the Jose's book, Ferreira's book on structure and mathematical practice. Can you put there a good quote about how important learning is about to do with like the knowledge how that students take? Because one thing I found very frustrating about this book is that there is a very large literature in epistemology about knowledge how that it doesn't even mention. Right? Like in fact, he's talking all about like propositional knowledge of facts.
Right.
And I think your idealized model is cool as well, but it does the same thing where it's sort of just about expanding sets of propositions. Right? And I think a far more interesting model of learning involves learning like a combination of facts and abilities.
Right.
So to make a bit of headway in understanding learning, we also need to like give up some like what I call the like intellectualist motivations.
Right.
The epistemologies we have. I think we need to be more open to like other philosophy.
Right. So Fenner is pushing on so there's a big literature in traditional epistemology on knowing how as opposed to knowing that, and he was mentioning that he would have liked it to be more present in Jose's book and also in my account. I think in my account, it is clearly because then you have rules that you apply. So this is really knowing how. So it's like, okay, how do you know that you can, you have the rules that you cannot pass on the red light and you can pass on the green light. This is a form of knowing how. It's a basic form of knowing how, but that's a rule that you apply to get your actions. So I don't see why it's not propositional. It's actually all dynamic, and so it's changing propositions. You can acquire proposition by applying, making an inference. Making an inference is applying a rule. So of course you need to know how to apply a rule, but it's very simple. But it's still not knowing how. Nonetheless, it's not propositional. So maybe you would like to have the account of rules more developed. What does it mean to know a rule? And then you get into Wittgenstein rule following problems and stuff like that, which are why not? This is what you would like to do, right? I don't think it's problematic, but that's another problem. But I don't. It's not like purely propositional. Like things, like people, agents have to do things to get more and more knowledge and have to apply rules, and you need to knowing how to apply the rules.
But like, I mean, the classic case is like knowing how to ride a plane isn't some set of knowing rules, right?
Yeah, but there are things that are knowing rules as well, right? So
yeah, sure, but it's a subset of the interesting case.
Yeah, but I mean, it depends. What's in is mathematics like more like riding a bike, or is it more like applying rules on going to the going through if you have a green light or red light?
I think it's obviously more like the riding a bike.
Yeah, but then you have to show that. Yeah, you have to write papers like for that. Are there other questions? I think we have to stop soon. What?
Thanks a lot. I find it very interesting, of course, but I also agree. But I was wondering, you made this distinction between, in a sense, kind of traditional philosophy and then philosophy of mathematical practice to illustrate kind of which ones are more, should be more interested in learning. And one way of making this distinction between these two is kind of about the kind of the questions that they're asking, like you mentioned, metaphysical questions and one could also, in a sense, make a distinction between whether we conceive mathematics as being done by people, agents, right, or whether we conceive of mathematics as this idealized abstract structure,
right?
And that cuts a little bit across this other distinction,
right?
So, what do you think of kind of making that as the main distinction, and then saying, well, people who care about mathematics are actually being done by people when they should care about learning, because that's what people do.
Right.
If you care about it as this kind of dehumanized thing or something like that, then learning is not an issue because
right.
The person.
So I think so. Dick is suggesting another distinction. Which is in terms of whether you think of, let's say, mathematics in terms of its subject matter, let's say, so like the object it is about, and if you think of mathematics as something that people do, and so if you think of mathematics as something that people do, at least if you want to account for what mathematics is by telling what people are doing, then learning is really important. But if you're interested into accounting for the structure of the mathematical edifice as such, for instance, if you're a logician and then your goal is to give a foundational framework or explaining how different mathematical theories are related to each other, so typically the work that Hilbert is doing and what people do in mathematical logic, then learning will not be important. So I think that, yeah, that's a good way of putting it as well. But the thing is that for the analytic philosophy of mathematics, due to the binary problems, there is the idea that you can tell your metaphysics, but you also have to an epistemology that works with it. And so I don't know where these people stand, because maybe they won't agree that mathematics is only about doing, and they are also think that there is more than just the object. So yeah, we have to see how these two things. But yeah.
Okay, I think we should break there. Let's thank you to you first. We should have a 5-minute coffee break. So please get your coffee and come back.
So we reconvene a little bit after 11:30, but not much. 35. That's
10-minute coffee.
So that should now be working. Hopefully the online people can hear. So Valeria is going to give the last talk of our workshop. Over to Valeria.
Thank you very much, Matthew. So thank you to Yasin for having organized it. And thank you for all the other speakers. As you said, it's the last talk. And so my talk has changed a bit in the last 3 days, kind of trying to react to what was said. And unfortunately now my PDF was fixed this morning, so I can't react directly to what was said, but I hope that I will do it during the talk. Before starting the talk, I have to make a comment on some of the things that Matthew was referring to. I realize how lucky I've been in my when I got my position, because first I was affiliated to a lab, which is the Archives Henri Poincaré in Nancy, where there were lots of historians of mathematics and historians of technology, which was an opportunity for a philosopher to be in an environment of people doing things that are close to the practice of mathematics and also some cognitive aspects of it. And now I am in a department of cognitive science, and it's true that we have a master, which is the Cog Master. He's going to change the name. And there's a track in the master, which is philosophy. Is not common. I think it's the only master, together with Lyon in France, where we have philosophy as part of the education of master students in cognitive science. So back to the diagram that you mentioned. We're pretty proud about it. And I have to see that in the years, I would say the students that are coming more to our classes are neuroscientists that really need the questions, have lots of technology, and are really interested in discussing things like consciousness. And so I think that it's an environment in which I think philosophy, not so much mathematical cognition, but there's a lot of philosophy of cognitive science that is happening in my lab. And so I just wanted to mention that I'm pretty happy about it. So I'm going to talk about how to go from the research to the class. So I'm not talking, I won't talk so much about mathematics education for the reason that I don't know much the literature, but I know better the literature in cognitive science and mathematical cognition. So maybe it goes back to some of the issues that you were mentioning. So what is the point of all of that? And really this talk is conceived as an occasion for discussion. So it will be mostly questions or proposals that answers. So one issue that is very important, and I've been working around this issue for a while now, is how we can get from the lab to the class, which is not so from quantitative research done in the lab in artificial conditions to the class. How can we use what is done in cognitive science into the class? And in this framework, what is a philosopher doing? So how can an armchair philosopher do and contribute to this debate? So first of all, let's accept there was a lot of discussion about it. This is the people that are interested in the practice of mathematics are not doing armchair philosophy, at least to some extent. So I want to think more in terms of people that are happy to discuss with practitioners, no matter if they are still alive or not, because they are historians. There are some interesting things about practitioners. So my question would be, how can we collaborate and in getting from what we're doing to the kind of intervention that can be done in the class? So in my talk, I will try to discuss one example of the kind of input that the philosophy of mathematical practice can give to research in cognitive science in relation to mathematics education. And I will focus on the notion of cognitive artifact, which is one of the notion that I've been thinking about a lot in the past years. My take-home message, just to give a spoiler from the beginning, is that it is very much necessary to distinguish between several cognitive levels that needs to be disentangled when we talked about cognitive conditions behind mathematical performance before getting to the class. And I will say more about it at the end in my conclusions. So the example, I know that we are many of you in the room are aware of this research, but let me summarize it for people not knowing it. So there's been, I think that Brandon mentioned it in his talk, there's been an enormous amount of research on 2 Amazonian populations. Among others, there are other populations that have been studied, but these are the most famous studies. So there were the
these hunter-gatherers, the Munduruku and the Piraha, were studied a lot. They had a limited vocabulary for numbers, so they were of interest for linguists. To go back again to the diagram, they were shown that they are perfectly able to compare and add approximately large numbers beyond their naming range. The same effects are found in Western adults as controls, and similar results are obtained for the recognition of some properties of shapes. Again, I'll be very quick on this because I suppose that many of you are aware of these studies. But these are the kind of studies that were given that we can discuss in the questions if you want about the methodology of the studies. But basically, the first case is the case of the Piraha, and this is the way in which they were asked to compare between two numerosities. And then in the second case is the Ann and Alia paper, and they basically were asked to pick out of 6 figures the weird one. And of course, the other 5 figures are grouped based on some kind of geometrical property. You can ask me more in the discussion. So, however, even if they're able to do this comparison, they do not seem to be capable of giving exact solutions to arithmetical problems that imply number greater than 4 or 5. And they also show to have difficulties with geometric transformation that imply mental manipulations. And I want you to point I want to really focus on one part of the paper that I think has been not considered so much. This is the paper from Deanna and Italia, so it's the one on the Munduruku, and when they talk about what they're doing, their habits, let's say. So they live, and I'm quoting, widely dispersed villages, so they can orient themselves in these villages. They have some symbolic miniatures, so they have some kind of art, but that's what they say. The Munduruku do not typically possess maps or spontaneously draw pictures of their houses, villages, or environment. And I think that this is an important point that I want you to think about, and we will go back to that. So why I think that this is important, we're looking at the details. And I want to point to another paper, and it's more recent. It's a paper that has been published in 2017 by Dylan and Talia. In the Alia, there are Elisabeth Spelke and most importantly for France, Esther Duflo, who just got the Nobel in economics. So he's trying to imagine interventions in places of the world that need support. So what they did, they conceived this kind of game-based preschool curriculum that was intended to exercise children's emerging skills in number and geometry. And they had this kind of randomized field experiment with 1,540 children, the average age of 4.9. And this was happening in India, and it was happening in 214 Indian preschools. And it was a 4 months intervention. So they were starting, they were starting from 2 hypotheses that go back to what we were talking about the Munduruku and the Piraha. So from previous research based on robust correlations and laboratory studies using short-term training, we know that there are universal emerging mathematical abilities that would improve with exercise over the preschool years, which is precisely the kind of early emerging mathematical abilities that were found also in populations with limited language. And they also hypothesized that such exercise would enhance children's subsequent learning of primary school mathematics. So what happened? Well, they got a negative result. So of course, if you are improving, if you are training the early emerging mathematical abilities, they will get better. But this doesn't mean that their mathematics would be better. So what the researcher says is that it's very the ecological conditions become very complex. It's very difficult to go from the lab directly to the class, especially in these kind of classes that also are in an area of the world where maybe that's far from us. And they think that there are 2 ways to redesign intervention that will make it more successful. So the first thing, this is what the authors are suggesting. First of all, Non-symbolic mathematical content, which is the one that we saw with those populations, so comparisons in non-symbolic comparisons and shape or geometric properties recognition. Non-symbolic mathematical content should be connected directly to the mathematical language and symbols that are used in schools. And non-symbolic training should coincide with children's learning of formal mathematics rather than preceding that learning. And what they did say is that the future field experiments could test these and other possibilities. And there's a more recent paper where, in fact, they are testing the use of maps. They are also adding some task that has to do with the use of maps. So why is this important? What are we talking about here? And we saw in Munduruku and pictures that there are some talk about maps or pictures. We talked about mathematical language and symbols, formal mathematics, and so on and so forth. And this is where I would like to go back to this quotation that I like a lot from an anthropologist, just to make, let's invite anthropologists to be part of the discussion, who's Jack Goody, who's been working a lot on writing. And he talks about the mathematical table, but it's just an example, and he says, and I'm quoting, is essentially the product of writing, but one that can be taught to and learned by those who can neither read or write. Not sure to discuss, but I think that I like about this quotation is that it says it provides those who use it with a special cognitive tool, a technology of the intellect. And I really like this idea of thinking in terms of these tools as a technology of the intellect. We had to talk about also theorem provers as a possibility and a possibility of intending them as a technology, and then what it means and what the consequences are. So in this context, I've been referring to some work that Dirk referred to, that is work from Sibylle Kremer, who talks about, in terms of operative iconicity. So all these kinds of tools that we have talked about, even a table, I would define it as cognitive artifacts. And why are they important? Because, and here comes this quotation here of Sibylle, these are objects in which the opposition between, on the one hand, image and on the other hand, language is not working. This is the class that she defines as the diagrammatic. And the idea is that these objects create what she defines as an operative iconicity. Katerina was mentioned too. In her previous book, she worked a lot on this idea. So the point of these objects is that, as a map, for example, is that they are on the one hand representations, because you are representing something by them, but on the other hand, they are also tools to work on these representations, or even to generate new things. Of course, for philosophers, generating new things is not enough. What's a thing? But I won't go into that here. So how can we go further? So let's imagine that we get this notion. So one question that could be asked is, what are the features of cognitive artifacts to be cognitive artifacts? How do they work? What kind of technology do they represent for our intellect? And here also it touches question that Brandon was mentioning, and in Natalie Sinclair's talk, we talked about embodiment and all this kind of stuff, but I won't go into that, but that's another way to go if you want. And what skills, what kind of basic abilities do they mobilize? And I'll try to focus on this question, because I think that is a question on which a collaboration can be built. So this is one way in which I think philosophers and cognitive scientists should help together in order to understand what happens in the class and how to intervene in the class. And I think that I would propose, but again, it's just it's a proposal, as I told you, it's a talk that is conceived more as to open a discussion than to give solutions. So two possible points, I think, for education. The first is of thinking in terms of representational affordances. And here's where I'm a bit worried, because I don't know enough the literature in mathematics education, and I'm sure that affordances are everywhere. But I'll try to give one way of intending this notion. And then also, this is something that is something that has been already put forward in the literature, but it's really thinking in terms of aspect seeing in mathematics and its relation with perspective taking. But this is just an idea that I would like to just flesh out for you. So again, this is not the kind of audience where you need to define Gibson affordances. I mean, the term affordances that was introduced by Gibson in his book on vision. But I must say that I love this quotation. I would like to write like something like this at some point when he says, the verb to afford is found in the dictionary, but the noun affordances is not. I've made it up. Great. I mean by it something that refers to both the environment and the animal in a way that no existing term does. So as you know, the idea of affordance for Gibson is this idea that in fact, if you're studying vision, you are not studying the world, but you're studying the environment, which means the kind of relationship that you have with the world. So if physics is studying the world, psychology should study instead the environment, and so should consider other kinds of properties in the objects. And for example, he says, a surface that is horizontal, flat, and rigid for physics. So if you consider it as part of the world, as part of the environment, it would afford some kind of support. As for example, the stable, that's some physical properties, but we can put computers on it. So the idea is to think in terms of affordances also when it comes to notations and diagrams and writing in general. So what I've been arguing for is that these kind of objects afford certain actions. I put some objects. So these the arrow diagrams is the diagrams that we've been working with Silvia, and I can say something about how they work if you're interested in. This is just some kind of notation that comes from. It's a part of the formalization of the construction of a torus. And then the last bit is LaTeX, and there's something to say, I think, about mathematics in LaTeX, that it's interesting, and the way in which it has changed mathematics, and it didn't. So I think that these are all interesting case studies. So the idea is that if we think in terms of affordances, we think in terms of these kind of objects as becoming more dynamic. So they're static objects, but they become more dynamic. And also, this goes back to some of the things that were said before in the conferences. So, of course, some affordances of these objects would depend on our cognitive system because they are objects as other objects. So, for example, one thing that I always think about is that, the arrow diagrams, for those of you who know how they work, it doesn't matter that they are squares. They could be rectangles or anything else that has four sides, but we like squares. And so this is something that, of course, have an influence on the way in which we define our this kind of tools. But then there are other kinds of affordances that depend on the practice that are recognized only by experts. So I go back to some of like permissible actions is a term that was used by Brandon. Legitimate operation is a term that was used by topologists that we talked about, Alexander. And so I was this is a way in which we can think in terms of tactics that were mentioned in the first talk, just to close the circle. So the idea that you're learning how to use these tools, how to what kind of actions they invite you to perform on them. And the idea is that if the tool is well designed, this kind of affordances should correspond. So annotation should invite you to be manipulated in such a way that it corresponds to a meaningful operation. And so we can address questions on designs also for notations. And this is part of Dirk's work about notation. So what is the important question of education, if this is the case? So, of course, the question for education is how can we be sure that students are not following bad affordances? So, for example, there are affordances that are inviting them to do things that don't correspond to any kind of mathematical operation. It's a big question, and I'm wondering whether recognizing or showing that there are affordances is already a good start. So I think that we missed that this is open. Is a question that maybe can be operationalized in some ways, and this could be one way to go. Another way to go is this idea of aspect seeing, and again, just to have fun with quotations, I like. This is from Wittgenstein and from the remarks of the Foundation of Mathematics, and it's a quotation that I think it's very. I think it has been discussed for other reasons in philosophy, but I'm interested in another part of it. But we'll see what I mean. So he shows this diagram, and he says a rectangle can be made of 2 parallelograms and 2 triangles, and this is the proof. Of course, he says proof. Huh? So, a child would find it difficult to hit on the composition of a rectangle with these parts and would be surprised by the fact that 2 sides of the parallelograms make a straight line when the parallelograms are, after all, askew. I can imagine the child, after having put the 2 parallelograms together in this way, not believing his eyes when he sees that they fit like that. They don't look as if they fitted together like that. It's only by hocus pocus that it looks as if they yielded the rectangle. In reality, they have changed their nature. They aren't parallelograms anymore. So apart from the changing the nature and aren't parallelograms anymore, which is something that has been discussed a lot in philosophy of perception related to the dark rabbit illusion and so on and so forth, what I think is interesting here is that I think it gives an idea of what a practice is in mathematics to some extent. It's like you have some particular tools that you are related to each other in some particular ways, and you learn how to use them and how to manipulate them and how to make sense of new things that are emerging from the manipulations. And I was wondering whether, of course, sorry, I didn't, for me, it was like of a given, but why aspect seeing? Because you see different aspects in these objects, and then you put together some different aspects, and this creates also new aspects that relate to the first ones. So I've always, this is again one question for education, but again to try to get to what are the conditions, the cognitive conditions to imagine these kind of things. And I think, I mean, that there's some work that might be of interest to look at perspective taking skills that and how they might help with this kind of reasoning, with this kind of aspect seeing kind of reasoning. And I want to mention that I look at a recent paper in education, maths education. So this is working with, I think, students, I think it's students or pupils around 12 and 14. So they are, they're not in the elementary school. And there is this idea or this discussion about how spatial skills can help in geometry. So, for example, these are the kinds of tasks that are given to support geometrical reasoning. But again, there's also a folding case. So the idea is that you have to imagine what happens when you fold a paper such as this one. So I think that here again there is a lot of a territory to explore of what are we really want to say, what kinds of skills are we talking about, what kinds of competences are we referring to, what kinds of competences this kind of task would support. So again, what we learned from these examples. So I think that one important take on message is that it is necessary to disentangle among the different competences that are required to do mathematics, to really understand their cognitive conditions, and as a consequence to define useful educational strategies. So we talked about this idea of creating distinctions that can track or explain some behavior. And I think that there's a lot to do yet. It's very complicated. And the philosophy of mathematical practice can offer some proposal looking at, for the reasons as we said with Yasin, that we're looking at expert ways of doing mathematics. And so trying to make sense of the cognitive conditions for it. So the point is really, and I think that it's really something that it's there. And I really liked what Matthew told us this morning, like the story. I really think that it started with Piaget. Karen will mention it. So it started with developmental psychology that became education. And there was a lot of work in reaction to Piaget, like to kill the father. And there's a lot of mathematical cognition now. And now there is like an incredible amount of research, but still I think it's getting a bit everywhere, and there is a need for some kind of conceptual neatness. And I think that here is one thing that we can do together. So what really are these building blocks of mathematics? Is not core knowledge system, is not only core knowledge system. There's a very important part that it's our symbolic nature and the use of our representations. There's a lot, I think, still to do here on this point. And just before coming here and taking my train to London, I found this very useful read on this point. So kudos to the center, which is Gilmore's paper on precisely on things that relate to what I'm saying. So Camilla Gilmore, who's here in the center, discussed about the possibility of intending mathematical cognition in a framework that is multi-level. And I think it makes a very good job, and also especially talking about getting to the interesting, relevant literature. I think it's really, it gives a map of the literature in mathematical cognition, and more importantly, the relations between the different literature. So the idea is that we have to distinguish, according to her, between, we have basic mathematical processes, core knowledge system, and so on and so forth. Then you have proficiency with specific components of mathematics. What are they? I think that it's still open and we can discuss what are they. Then you have overall mathematics achievement. These are things that we can measure. And we also have general cognitive skills. And she tries to make a map of how all this literature is related. And then, of course, she says, well, and also we have the influence of how mathematics is learned and taught. So this is the picture. And we have to assume that this is it. So it's complicated. And I want to quote some of the passages, because I think that really it's in connection with what at least I've been doing in my work, but I think that many of the people interested in cognitive aspects of mathematics have come up to. So she says, mathematical cognition research addresses questions such as how uniquely human system of symbolic representation integrate with evolutionary old intuitive systems for representing mathematical ideas. This is the very important question, and I think that is still not answered properly. Not because cognitive scientists are not paying attention to it, but it's very, very complicated. And then there is also, she also has this question on affective processes. I must admit that I never was very much interested into this affective aspect, but I understand that it's very important. And then she says, well, the proposed framework is not a model of mathematical process, but a structure to make sense of existing empirical evidence. And I think really it's going back to the idea, is this philosophical work or empirical work? I think that if you intend philosophy as a conceptual analysis, I think that there's some philosophical bit here. And I think that this also is a very important point. Mathematical cognition research has flourished over the past 2 decades. But before this research can have a positive impact on education in the classrooms, we need to recognize the complexity of mathematics and to identify how children's experiences influence learning. And I think that this is a very important point. Matthew addressed a bit this idea of cognitive science of mathematics. So it's not mathematics education, it's really working on the conditions, the cognitive conditions for mathematics. There's still a lot to do, but in a good sense, in a positive sense. So I hope that I show that there are lots of questions on which we could collaborate as philosopher and cognitive scientists. So this is so consider that these are you don't know who they are, right? They probably have a map. But apart from that, you don't know who they are. So the idea is, let's collaborate. We can collaborate at different steps. So before the experimental research, after on how to get from quantitative data to the classroom, and also after interventions, as it was the case for the Dillon paper. So I really liked Keith when he said, "Oh, we are not reckless, so we already have our the things, the hypotheses that we want to test. It's not that we're starting, we're just exploring or being very descriptive." And I really liked when he said, "I armed myself with brilliant ideas." Why arming yourself? Because it's a dangerous place. And I like this quotation that is not directly connected with our topic, but with cognitive history. So it's another intersection. But I really like Ned's quotation here because he says, and it goes back also to the journal issue this morning. So again, this is another context. It's cognitive history, so it's not the kind of research. But he says it's an intersection that is an interesting but dangerous place to be in. And in fact, he says, in his case, is in between cognitive science and historians. And he said, well, cognitive science may see this study as too impressionistic, while historians may see it as over-theoretical and too eager to generalize. Perhaps both are right. I beg both to remember I'm trying to do what is neither cognitive science nor history of ideas, whether I have succeeded or whether this is worth finding. I leave for the reader to judge. So it's really something that has to do with what you said today about interdisciplinarity. So how can we make it happen? Personally, I had it wasn't really a project, but it's very, I'm not the center of for mathematical condition, and we are talking of very, very small amounts of money to invite some people. But we had a first discussion that was open in 2016, 2019 in Nancy, where I was in Nancy. Dirk was there, David Landy was there, Natalie Sinclair was there, Yasin was always there, so if I don't mention him, he was there. And then now we have this discussion on cognitive artifact that it's open with cognitive scientists in Paris, Véronique Izard, Arnaud Villarouge, Marie Amaric, who's not in Paris, but close to Paris. We didn't come with anything, but so I like this success story. I hate the term success story, I must say. So this is not a success story, but I want to end my talk, and I think the conference, with a more positive note that good science takes time when it's a good day. And this is also for one of Brendan's t-shirt. I would like to put that. And so I think that it's a long way to go, but I think that really the kind of things that Mathieu was suggesting to really create the collaboration. I mean, not doing interdisciplinary après coup, as we say in French, like after, but really we have, and there are lots of institutional problems and difficulties, but I think that if that's what we want to achieve, we should spend some time and energy on it. And this is it. Thank you.
Great. So we've got about 10 minutes for questions.
Thanks very much. I have a question about your account of the affordances, right? Because you said you described them as saying they depend on our cognitive abilities, like they depend on somehow on the physical or perceived somehow, and then they depend on the practice. And then from that you concluded that we can use them in order to perform meaningful operations.
Yes.
And my question is, where does the meaning come from there? Because even in your diagram, right, I can see the physical aspects of it. I can see the how I perceive my cognitive abilities are not allowing me to recognize them in some way. I can also see how experts use them, but how do I find out what they mean?
Okay, so the question for the people online is Dear's question about what it's meaning when we're talking about affordances, depending on the practice. So how do we find out what the meaning of this diagram is? these are kind of affordance. So okay, I insist that there is still an importance in the way in which some of these affordances are really depending on our cognitive functioning.
Yeah.
So because they influence a lot the interpretation, because the second step is the interpretation. So we get that from the kind of things that we know about other pieces of knowledge, other things that are related to the practice. So I would say, I don't know if I get to what, if I'm respecting your question, but my reply would be that no diagram is considered in isolation from other diagrams or a system of representation. So the meaning of this diagram is, what an arrow diagram is and how it's used and what it alludes to, what kinds of instruction it gives, and so on and so forth. One thing that it's a problem with these affordances, I think it goes back to your talk when you said, and I wrote something about that too. So these diagrams are intended for some particular aim. So we discussed a lot with Sylvia knot diagrams, why knot diagrams are as they are, because they could have been different, but there are cognitive good things about the fact that we represent knots in that way. But it's true. So all of this, and this is a question of design, all of these objects has to be recognized as some kind of intentional objects. So they're given for some particular intention. But this could, at some point, you can have some kind of interference, and at some point, maybe you can change the interpretation of these objects. And this is a way in which, also for notation, maybe at some point you try to use it in a way that was not the intended usage, so in an intended way. And this, as you said in the paper, in your talk, would also open up other possibilities in mathematics, so other meanings. So there is a sense in which two things. So to sum up, first, no diagram is isolated, so it comes with a system of representations and diagrams. And the second question, and the second reply is sometimes things get weird, but maybe for the good reason, or for the good reason. We don't know. Maybe there are things that then are forgotten. I hope this.
Yeah, so I was very intrigued by the discussion at the beginning of the population
Mhm.
with limited language, and I'm not sure I understood correctly, but did you say that, so the end, one of the findings was that also affected their geometrical reasoning, so they were doing poorly?
Oh no, I don't know. I mean, it could be an explanation of why they are doing poorly in, especially the tasks that are implying mental rotations and transformation of some
So
kind.
they're doing poorly in those tasks. But so how do you interpret those type of findings, also with respect to your work on cognitive tools?
Mhm.
So in some sense, it seems that suggests a sort of interconnection between symbolic
Mhm.
representations and more geometric representation. Let's say, just to have a coarse grain distinction here.
Mhm.
And I wonder whether, what type of morals we can draw from this. If there's a continuity, or it's just like some of the same cognitive abilities are called
Mhm.
by these representations, or
No, it's a good question, and I can't reply. I think this is one of the questions to address. But for example, and that's why I insist on the idea on that passage that was written a bit, I think, quickly, about the fact that they can, these are populations that, of course, can orient themselves in an environment that is not ours at all. So it's very difficult for us to. So I think that when it gets to thinking in terms, as also we did in our paper, the kind of spatial skills that are recruited for geometry, I think we really have to make some distinctions, because it's already a special skill if you can orient yourself or navigate a space. It's already that. And also, anecdotally, I spoke to a man, I forgot his name, and I'm sorry, so I have to categorize him as one of the last members of the Yagan population in South America. And we discussed the way in which, so they are in Patagonia, and which is a very, very difficult environment to orient in. And in fact, I was shocked because I really wanted them to have maps, and they don't have maps. Because and also to go back to other things that were discussed. I mean, in Paris, they call it the sciences sociales, where there are lots of anthropologists, and there's a lot to say about other kinds of traditions like textile. There's a lot of mathematical information in these kind of objects. But for me, it is very important to make a difference between all these kind of things and the fact that then at some point you reflect on these practices and you draw you create some kind of symbols that reflect the practice. I don't know if this is connected with things that have to do with metacognition. I don't know. There's maybe more to say of reflection. But I think that this makes a difference, and it can have an influence on the kind of spatial skills that we develop afterwards. I think that's but this again, I think it's an open question, and it's not.
So just to follow up very quickly, I think this is really interesting. And so could you conjecture that symbolic reasoning is something that not only needs some sort of like spatial abilities, but also help us train those spatial abilities. And I mean, it seems clear that when we have also symbolic notations, both linear or two-dimensional, whether you want or not call them diagrams, doesn't matter. But there is some sort of like spatial abilities that's going on there when we manipulate these things.
Mhm.
That's not geometric in the proper sense,
Mhm.
but that might be. So that kind of activity might be something that enhances like our like spatial abilities that then we can redeploy for maps. Or
Yes, and
like
for
that.
example, about that, because I've been working with some groups that are working on education now. So also, I mean, in France, it's like in the UK, mathematics is very bad. I mean, it's not, the students are not very good, which is kind of surprising because at the same time, France has a lot of field medalists, but it looks like something, like the elite mathematics is very good, but the mathematics in the classroom is very bad. And for example, one thing that I think not many people are asking, and I think it's super relevant, is what is changing in children today, because they're moving all the time. They're imagining themselves all the time in 3D environments where they can move around things. And I'm pretty sure that this changes their way of imagining a cube or, I don't know.
So sorry, they're
Yes.
moving around.
I mean, if you know what children are doing with their video games,
Oh,
they
right,
are
they're
in
moving around
3D
video games.
environment all the time. all the time.
Manipulating stuff.
And we are basing our teaching of mathematics to children on the page, which makes sense because that's what we did. For example, I love Natalie's work because she really reflects about the use of touch screens. And it's something that sometimes is taken for granted, but she really worked on that. I mean, I don't know if you saw in the talk that you used to, so it's very explicit. But I think that now we are facing another era to some extent, and we are there. I'm not sure that there is enough reflection on the way in which really the environments of children are changing and how this might impact mathematics. Maybe it's happening. Maybe mathematics education is working on it, but. So yes, so two things. I think that spatial skills, depending on the kind of objects you use, you can enhance differently your spatial skills. And I also think that the fact that we have some particular representations and not others would have brought us, and this is for history to tell, to mathematical universes that we couldn't imagine without those notations or those symbols. So a kind of semiotic approach. And also to go back to this, I always tell this story, but because we talked about it. For example, one idea is that I would love to think that the Klein bottle was discovered just because you were playing with these squares, which is not the case. But the idea is that I would like to think of mathematics in terms of playing with these symbols and see what kind of abstract whatever content they might emerge from them. It's not the case again if you go to history, but
Great. I think one comment I'd just like to make. I think your example of understanding building blocks and for basic numerical cognition and theorizing that properly is a really good example of where some concept application could work. I think we're really hoping we've got a very poor conception of what a building block is, and particularly how it necessary building blocks that don't then correlate with individual differences up the ability to scale. It's just not something people theorise what they call it. Really nice to know. But I think we should stop there because we're a bit over time and we should go and have lunch. So let's thank our speaker once more.
But I'm the last speaker, so thank you. But since I'm the last speaker, I would like to thank again the organizer, in particular Yasin Amami, and and also all the other speakers. Thanks a lot. I know, it was almost a joke. Since they kept saying, it's Yasin, I took that literally. Thanks a lot.
Great, thank you everybody. I should say, if anyone is still around this evening, we've probably got some spare dinner places going. So just come and talk to me and you're welcome to come and have dinner in the hotel, which we paid for them before we knew how many people would be there.
I don't know how to do it. Thank you also to people who were online, if there were any.
Yeah, thank you very much to everyone online. So I think that we're going to have some of the talk. So I think on YouTube you can have a recording with the whole day, which is not crazy to navigate, but at some point we make a chunk and a nice video set up with all the talks individually on the Center of Philosophical Foundation website. But we'll send an email if you do that. Okay, I'm going to close now. Thank you very much for attending online. Thank you.